All right, here we go. This is Unit 7, Lesson 2. We're going to be multiplying and dividing rational expressions. So kind of like a big part of this is going to have to do with simplifying. And again, simplifying means getting rid of all the common factors. So like in this case, if it's A times C over B times C, C would cancel out and you'd just be left with A over B. It's kind of like this other example where we have 15 over 65. But we realize that 15 and 65 both have a factor of 5, so we can actually cancel it out. And it also works when we have, whole expressions that we can cancel out. Like, for example, in the bottom here, we have x plus 3 on the top, and we have x plus 3 on the bottom. So anything divided by itself is going to equal 1 and cancel out. So if we look at an example, let's say we want to simplify x squared minus 2x minus 15 all over x squared minus 9. Again, I'm going to have to do some side work. I'm going to have to figure out how can I simplify x squared minus 2x minus 15. So I'm going to think, what two numbers multiply to get negative 15 but add to get negative 2? And the only way to get a multiplier of negative is to have one positive and one negative. So I could do an x is a negative 5 and my other x is a positive 3. So I'm going to rewrite this top fraction as x minus 5, x plus 3. And then the bottom one, again, what two numbers, because I know that I have no middle term, I recognize this as being one of these examples so that my middle term cancels out. Because again, I don't have this middle term. So I'm just going to write x minus 3, x plus 3 down here. And luckily, and again, why we do this is because we have x plus 3 on the top and x plus 3 on the top. So we can simplify this all the way down to x minus 5 on the top and x minus 3 on the bottom. You're also going to have to multiply, so we can do another example of those. Oops, that's all right. We're going to crop it out anyways. All right, so kind of like very similar. Again, if we can multiply our numerators together and we can multiply our denominators together. Just remember, we can't have a denominator of 0. So if we look at this case, again, I multiply things that are common. So I multiply the 5 and the 6. I multiply the x's with the x's. And if I don't have another y, well, that y is going to kind of stand alone by itself. So we end up getting 30. Remember, if you don't have an exponent, it's on the top. So 2 plus 1 is how I get x to the third, and y to the third stays the same. We notice that 30 and 20 can cancel out a 10. X to the third divided by x, so I'm going to be able to cancel out 1x, and then y to the third and y to the third cancels out, which means after we finally reduce it all the way, we get 3x squared over 2. All right, so if I did an example of that, let's say we have 8. Ooh, that's too big. That's still, okay, that's fine. 8x to the third y over 2xy squared multiplied by 7x to the fourth y to the third all over 4y. So again, I'm just going to multiply things that are common. So yes, I've got some numbers here that I can multiply. I'm also going to highlight my x's. This one doesn't have an x on the bottom. That's fine. Then I'm going to look at my y's. All right. And I'm just going to add in, because I know if I don't have a number, I'm going to pretend it's a 1. So let's start simplifying. 8 times 7 is 56. X to the third times x to the fourth. 3 plus 4 is 7. Y to the first times y to the third. 1 plus 3 is 4. All over. 8 times 7 is 56, not 57. 2 times 4 is 8. X stays the same, and y becomes y to the third. Again, still looking at what I can simplify and what I can take out or reduce. And I see, hey, we have, first off, in our numbers, 56 and 8. And I actually know that 8 is a factor of 56. So we can divide by 8 and divide by 8. And so we are left with 7 on top. And then that's just going to be a 1. You can put the 1. We don't need it. X to the 7th divided by x to the 1st. That's like saying 7 minus 1. So I'm going to have x to the 6th on top. And then y to the 4th over y to the 3rd. 4 minus 3 is 1. So I'm just left with y. So really, I could write this as 7x to the 6th y. Because that divided by 1 doesn't change the problem. Okay. Again, these problems can be kind of labor intensive, so it's very important you be clear with your notes and you are writing slowly and clearly so that you don't miss a step or mistake something. All right, first thing I'm going to do is I'm going to factor my numerator and my denominator and try to see, hey, is there anything that we can cancel out here? So if I'm looking at this first one, I see I've got a 3 and an x in each. So I'm going to factor out a 3x, and I'm left with 1. And then since that's an x squared, we still have an x left over. If I think about my factor x, what two numbers multiply to get -5 but add to get 4? That's going to be +5 and -1. So I'm going to rewrite this as x minus 1, x plus 5. And then over here, what two numbers multiply to get -20, add to get 1? That's +5, -4. So I'm going to have x plus 5, x minus 4, and you can't do much with 3x. Now, because I'm multiplying, I am going to combine them and push them together, I guess. So we're going to have 3x times 1 minus x times x plus 5 times x minus 4 all over. Again, just multiplying 3x, x minus 1, x plus 5. Now, I do see some good things here. I see that I have a 3x divided by 3x. It's going to cancel out. I have x plus 5 and x plus 5. It's going to cancel out. Now, I'm really close right here. So I want us to focus on this. This is 1 minus x and x minus 1. So what I'm going to do is I'm going to factor out a -1. So I'm going to make this, I'm going to factor out a -1 from that top example. And so that's going to end up being -1 plus x. Everything else is going to stay the same. And now, again, think about it. -1 plus x. If I just rewrite that, that's the same thing as x minus 1. So I can actually cancel out one more step here. Oh, this was canceled out as well. This x plus 5 is not here. So we have actually canceled out everything on the bottom, which means our final answer is just -1 times x minus 4, also known as -x plus 4. This is a lot of work to get that one problem. Whew, okay, let's see here. I want to just show you all the examples. Again, I know it seems kind of repetitive, but I want you to get more examples than less. So if we take x plus 2 over x to the third minus 27, and then multiply it by x squared plus 3x plus 9, and there's nothing underneath it. Remember, you can always write this equation over 1. So now you can combine it. We can say we have x plus 2. Let's factor this equation out. Two numbers, add, multiply to get 9, add to get 3. I'm not sure about that one on the top of my head, so let's see if there's anything else that we can do. Because I bet if we continue, so we'll just keep that one the same. And then we say, all right, well, on the bottom here, I have x to the third minus 27. That's like saying x minus 3 times x minus 3 times x minus 3. If I factor one of those out, all I'm left with is x squared plus 3x plus 9. So now I've got the same thing on the top and the bottom, so I can cancel this out, and I'm left with equals x plus 2 on the top and x minus 3 on the bottom. And then just again to clarify, the last examples are about dividing. So if you want to look at these examples real quick. Again, just trying to find anywhere that you can simplify, any time that you can remember when we divide fractions, we multiply by the reciprocal, which we remember as keep, let's see here, keep, change, flip, which is how they got that. And then again, they did that down here as well. Keep, change, flip. So we'll do 2 examples, and then that will be it. I know these are getting long, but they take a long time to solve. 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So first, again, if you divide these, I'm going to keep my first term the same. I'm going to change this to multiplication, and then I'm going to flip my numerator and my denominator. Now I'm going to try to simplify anything I can. 7x can't do much with. This one I can factor out a 2, and I get x minus 5. If I do my factoring x right here, again, what numbers? Multiply to get 30, but add to get negative 11. That's going to be negative 5 and negative 6. So I'm going to write this as x minus 5, x minus 6, and this one you can factor out an x and get x minus 6 over here. So when we combine these, I think it's going to work out relatively nice for us. And again, you can kind of see one of the big points, or one of our main points when we're doing these, is to factor things out. So if you're not getting anything factoring out, double check your math, because you might have missed something. So all we have left with a final answer of 7 over 2. Last example. Do green. 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. Again, keep, change, flip. So that's your first step, is to rewrite this. Multiply and then put a 1 on top. Now you want to look to factor out anything you can. Let's see here. These ones, when the coefficient in front of x squared is not a 1. It's a little bit trickier, but this one we can actually rewrite as, again, how do you get 6? You get 3 times 2. So 3x and 2x. And then how do I get 15? That's with some combination of 5 and 3. So I can rewrite that. Again, multiplied by 1 at the end. That's not going to affect my problem. And then this one, I still have 4x squared. I can factor out an x from this and get 3x plus 5. So I will do that. I will factor out an x and say that this is 3x plus 5, which is nice because I see that we have 3x plus 5, 3x plus 5. So we get 2x minus 3 on top. 4x squared times x is x to the third. So your final answer is 2x minus 3 over 4x to the third.